Okay, good morning. Welcome to
FamilyMath number 843.
FamilyMath843. So today it's just me and you, your brother's away at camp, and we're going to talk about Graham's number, which we haven't talked about in, I don't know, 3 years probably, but just tell me some of the few of the things you remember about Graham's number.
So remember that it's really big.
Okay.
There was this new notation that was kind of, I think it wasn't made for Graham's number, but just kind of adapted for Graham's number.
Uh-huh.
Where it's like, you have 3 and then you have these arrows. Some amount of arrows and then another 3.
Yeah. So Graham's, one of the actually great descriptions of Graham's number that I learned from Evelyn Lamb is that it's too big to actually describe how big it is. But this arrow notation, which is another operation that, like multiplication or division or exponents, this arrow notation actually helps describe it. Okay.
And then I remember that it's so big that I think that if you had every particle in the universe, it's bigger. It's a bigger number than there are particles in the universe.
Yeah, that's true, but there's only 10 to the 80th particles in the universe, or maybe 10 to the 200th or something like that. So
that's kind of, I guess it's not that big of an accomplishment.
Yeah, so it's interesting because I think that description is not so good because that number is so small compared to Graham's number that it's nothing. But what they're saying there when they talk about that you couldn't write it down.
Yeah.
There's actually not enough space in the universe to write down the number if you're going to try to write down all the digits.
Yeah. And remember, you can find the last few digits of Graham's number.
Yeah, that's the surprising thing.
Someone found like there's like 500 or something digits.
Yeah, Wikipedia has the last 500 digits. Good memory. And that's actually what we're going to do today. It's the amazing thing about Graham's number. It's described in this bizarre notation. It is so big that you couldn't write it down, even if you wrote each digit in the size of a Planck length in the universe. But strangely, you can actually write down the last several digits, and that's what we're going to do today. Do you have any idea how it comes to pass that you can actually write down the last several digits of it?
Well, for the last digit, I think there's only so many numbers the last digit can be. Since we're looking, Graham's number is made with powers of 3.
Okay. So Graham's number is a power tower of 3s. So why don't you write a power tower for those?
3, 3, 3, 3, 3, 3. Yeah,
you don't have to write all the digits. Good. And the way you evaluate power towers, just remember, is from the top down. That's basically the only thing we know about Graham's number, is that it's a power tower of 3s. But funny enough, that allows us to write down the last digits. So we'll try this. We'll see what we can do. We'll do the last digit on our own, and then we'll go to the computer for help.
All right.
On the next ones.